Something very strange is getting worse in deep space, and scientists can't explain it. There is a region in deep space where reality is not behaving the way it should. Not metaphorically, not theoretically, observably. Light passing through this region arrives distorted, delayed, sometimes even duplicated, as if space itself cannot decide how to carry it. Signals that should be consistent begin to fluctuate without cause. Entire zones appear to bend subtly out of alignment with the rest of the universe, not collapsing, not exploding, but drifting away from the rules that govern everything we understand. At first, it looked like noise, a minor inconsistency buried in massive datasets. The kind of thing scientists are trained to ignore. Instruments fail, data corrupts. The universe is vast enough to produce illusions. But this did not behave like an illusion, because it did not stay isolated. Different observatories, separated by continents, began recording similar distortions. Independent systems, calibrated in different ways, started reporting the same quiet irregularities. Not identical, but connected, like fragments of a pattern that refused to fully reveal itself. And the deeper we looked, the more uncomfortable it became. Because this is not just about distant galaxies or abstract measurements. This is about the structure of reality itself. The silent framework that holds everything together, from the smallest particle to the largest cosmic web. A framework we believed was stable, predictable, and universal. Now, for the first time, that assumption is beginning to fracture. And the most unsettling part is not what we are seeing. It is the possibility that this has been happening for far longer than we realize. The first crack in reality. It did not begin with a discovery. It began with hesitation. A small inconsistency appeared in the data, the kind that scientists are trained to question, not announce. A signal that arrived slightly out of phase, a fluctuation in brightness that did not match any known behavior. At first, it was treated as a technical issue. Instruments recalibrated, software rechecked. The assumption was simple. The error was human, not cosmic, because the alternative was far more unsettling. As observations continued, the anomaly persisted. Not dramatically, not in a way that would trigger immediate alarm, but quietly, almost cautiously, as if it did not want to be noticed. A subtle shift here, a delayed signal there, each instance small enough to dismiss on its own, but together forming something that refused to disappear. This is where the first crack appeared, not in space, but in certainty. Scientists rely on patterns. The universe, at its core, is predictable. Light travels at a constant speed. Gravity behaves consistently. Signals, once emitted, follow paths that can be calculated with precision. These are not assumptions. They are the foundation of everything we know. And yet, in this region, those foundations began to waver. The same signal, observed twice, would not always behave the same way. Light passing through similar paths produced different outcomes. Time delays appeared where none should exist. It was as if the universe, in that specific place, had stopped following its own rules with complete reliability. At this stage, no one called it a phenomenon. They called it a glitch, a temporary inconsistency, a statistical anomaly, something that would eventually correct itself once enough data was gathered. Because accepting anything else would mean questioning the very framework of physics. But the glitch did not correct itself. It stayed, and more importantly, it repeated. What began as hesitation slowly turned into something far more dangerous. Doubt. Not loud, not public, but present. The kind of doubt that grows in silence, behind closed doors, in conversations that never make it into official reports. Because if this was not a glitch, then something else was happening. Something that should not be happening at all. And that realization was only the beginning. Patterns emerge. At first, it was easy to believe the anomaly was contained. One region, one irregularity, one unresolved inconsistency. But the universe does not hide patterns forever. As more data was collected, something unexpected began to surface. Observatories that had never coordinated with each other started reporting similar disturbances, not identical in form but eerily aligned in behavior. Signals arriving with unexplained delays, light bending in ways that could not be traced to any visible mass. Regions of space where measurements refused to remain consistent over time. Individually, each case could still be dismissed. Together they formed something far more difficult to ignore, because now the anomaly was no longer a point. It was a pattern, and patterns change everything. Scientists began comparing data sets across different wavelengths, different instruments, different locations. What they found was not comforting. these distortions were not random. They appeared in clusters, separated by unimaginable distances, yet behaving as if they were connected by something unseen. Not a force we understand, not a structure we can map, but something that leaves an imprint, like footprints in a place where nothing should be able to walk. The most unsettling part was the progression. These anomalies were not static. They were not frozen in time like distant echoes of past events. They were evolving, subtle changes becoming more noticeable, minor inconsistencies growing into measurable deviations, as if whatever was causing this was not just present, but active, and possibly expanding. This is where the narrative began to shift. No longer a question of whether the data was wrong, but whether the universe itself was beginning to behave in a way we had never seen before. Because when something repeats across the cosmos, across vast distances and independent systems, it stops being coincidence. It becomes intention, or at least something that mimics it closely enough to make us question everything. And once that question is asked, it cannot be taken back. The data doesn't make sense. There is a moment in science when confusion turns into something deeper, not ignorance, not error, but contradiction. Because what began as irregular patterns soon collided with something far more rigid. The laws that define reality itself. The equations that have guided every discovery, every prediction, every successful model of the universe suddenly began to lose their grip on what was being observed. Not completely, not everywhere, just enough to be disturbing. Light, which should travel in a predictable path unless influenced by mass, began to bend without a source. Not around galaxies, not near black holes, in regions where space appeared empty. And yet, the distortion was measurable, repeatable, undeniable. Time, as inferred through signal delay, showed inconsistencies that could not be explained by distance alone. Identical emissions, traveling through similar cosmic environments, arrived at different moments, not by seconds or minutes, but by margins that forced scientists to question the very medium through which they traveled. Even energy signatures, which normally follow precise distributions, started to display anomalies. Slight shifts at first, then patterns that no existing model could reproduce. At this stage, the problem was no longer the phenomenon. It was the framework used to understand it. Because physics does not fail quietly. When something breaks, it reveals itself through inconsistency, through equations that no longer balance, through predictions that no longer match observation. And that is exactly what began to happen. Models were adjusted, variables reconsidered, unknown factors introduced in an attempt to reconcile the data. But each adjustment created new problems. Fixing one inconsistency would generate another somewhere else in a different observation, under different conditions. It was like trying to repair a structure that was shifting beneath your feet. And that realization changed the tone entirely. Because if the laws of physics appear to hold everywhere else, but begin to falter in specific regions, then the question is no longer about isolated anomalies. It becomes a question about uniformity, about whether the universe is truly governed by the same rules in every place, at every scale, under every condition, or if there are regions where those rules begin to loosen, not break completely, but drift. And if that is the case, then what we are witnessing is not just a scientific puzzle. It is a boundary, a place where our understanding ends and something else begins. What could cause this? Once the data refused to align, the search for explanations became inevitable, because science cannot remain in uncertainty for long without trying to impose order on it. The first instinct was familiar. Look for something massive, something hidden, a structure large enough to bend light, distort signals, and create the illusion of inconsistency. Perhaps an unseen cluster of matter, too faint to detect directly, yet powerful enough to influence everything around it. Dark matter became the immediate candidate. After all, most of the universe is made of it, and we still do not fully understand how it behaves. It does not emit light, it does not interact in obvious ways, and yet its gravitational influence shapes galaxies. It seemed reasonable to imagine regions where its distribution becomes irregular, dense enough to produce the distortions being observed. But there was a problem. Dark matter, as we understand it, still obeys gravity in predictable ways. It bends space, but it does not create contradictions. It does not cause the same signal to behave differently under identical conditions. It cannot explain why patterns would evolve over time in ways that appear coordinated. So the explanation shifted. Perhaps it was not matter, but space-time itself. Localized distortions, subtle warping of the cosmic fabric, not caused by mass, but by fluctuations at a deeper level. A kind of turbulence in the structure of reality, invisible yet influential. This idea carried weight. Space-time is not static. It can stretch, compress, ripple. We have seen it happen in gravitational waves. We have measured its flexibility. But even this explanation began to fall apart. Because these distortions were not random. They did not behave like waves, rising and fading. They persisted. They grew. They appeared in separate regions with similar characteristics, as if guided by something beyond simple fluctuation. Each theory, when applied, solved part of the puzzle, and then broke somewhere else. Gravitational lensing could explain the bending of light, but not the timing inconsistencies. Quantum fluctuations could suggest instability, but not the large-scale coordination. Unknown cosmic structures could justify localized anomalies, but not their repetition across vast distances. Every answer opened a new question, and with each failed explanation, the space of the unknown expanded. Because if no known force, no known structure, and no known behavior can fully account for what is being observed, then we are left with something far more difficult to confront. Not just that we do not understand the cause, but that the cause may not belong to the framework we are using to understand it, and that possibility changes everything. What if it's not natural? There comes a point where explanation gives way to discomfort, not because the data disappears, but because it remains, unchanged, resistant, and increasingly difficult to contain within anything we recognize as natural behavior. Up to this moment, every attempt has followed the same path. Assume a cause, test it against the data, adjust the model, repeat. This is how science moves forward, slowly, carefully, grounded in patterns that can be measured and reproduced. But what happens when the patterns themselves begin to suggest something else? Not chaos, not randomness, but inconsistency with intention. Because these anomalies are not behaving like accidents. They are not the result of a single violent event or a passing disturbance. They are structured, persistent, and in some cases evolving in ways that seem to follow a direction. And that is where the discomfort begins. Because the moment you consider that something may not be entirely natural, you are no longer asking what caused it. You are asking what shaped it. There is no evidence of design, no signal, no message, no identifiable origin. But the behavior itself introduces a question that cannot be easily dismissed. What if the universe is not uniform in the way we assumed? What if there are regions where the rules are not simply breaking, but being applied differently, not randomly, deliberately, or at least systematically? This does not imply intelligence. It does not suggest intervention in the way we might imagine. But it forces a shift in perspective, from a universe that behaves consistently everywhere to one that may contain layers, variations, or conditions that we have never encountered before. And if that is true, then what we are observing is not just a phenomenon. It is a boundary between realities that follow different rules, a place where the familiar ends, and something else begins to operate. The deeper implication is not that we are witnessing something unnatural. It is that our definition of what is natural may be incomplete. Because if the universe can behave differently in ways that are coherent, structured, and persistent, then perhaps what we call reality is only a local agreement. A set of rules that apply here, but not necessarily everywhere. And if those rules can change, even subtly, even far away, then the question is no longer confined to distant space. It becomes something far closer, something that touches the very idea of stability itself. We've seen this before, kind of. This is not the first time the universe has forced us into uncertainty. There have always been signals that did not fit, regions that behaved differently, observations that lingered at the edge of explanation, never fully understood, never fully dismissed. For decades, science has collected these fragments, anomalies that seemed isolated, disconnected, almost harmless in their ambiguity. But now, something feels different. Because when we look back, those fragments begin to align in a way they never did before. There are vast regions of space known as cosmic voids, areas so empty they challenge our expectations of how matter should distribute itself across the universe. These voids are not just empty. They are structured in ways that suggest something has shaped them, yet no clear mechanism fully explains their formation. There are also signals that arrive from deep space with characteristics that defy easy classification. Bursts of energy that appear suddenly, disappear just as quickly, and do not repeat in predictable ways. Some have been traced, others remain unresolved, cataloged but not understood. And then there are subtle inconsistencies in the cosmic background itself. Tiny fluctuations in radiation, slight irregularities in temperature, patterns that should be uniform but are not entirely so. Each one small, each one explainable in isolation, yet together forming a quiet tension beneath our understanding. For a long time, these were treated as separate mysteries, independent puzzles, each waiting for its own solution. But now, under the weight of what we are currently observing, they begin to feel connected. Not directly, not in a way that can be proven, but in a way that suggests a deeper layer beneath them all. A shared origin, or at least a shared condition that allows them to exist. As if the universe has been leaving traces, subtle signs that something about its structure is not as uniform as we once believed. And perhaps we missed it. Not because the evidence was not there, but because it did not seem urgent. It did not seem dangerous. It did not demand attention in the way this new pattern does. But now, with anomalies appearing again, repeating, evolving, those earlier observations no longer feel distant. They feel like warnings, not explicit, not intentional, but present. Because if the universe has shown hints of inconsistency before, and those hints are now becoming clearer, more frequent, more structured, then what we are witnessing may not be something entirely new. It may be something that has been building, something that has always been there, just beyond the threshold of our ability to recognize it. And now, for reasons we do not yet understand, it is becoming visible. The silence of science. When science encounters something it cannot explain, it does not panic. It becomes quiet, not out of fear, but out of precision. Because uncertainty, when handled correctly, is not announced. It is studied, contained, and approached with caution. Hypotheses are formed carefully. Language becomes restrained. Conclusions are delayed. And that is exactly what is happening now. There are no definitive statements, no bold claims, no declarations that something is wrong with the universe. Instead, there are careful papers, neutral wording, and an unusual absence of certainty where, under normal conditions, there would be clarity. Because the data is there, but the explanation is not. And in science, that is one of the most unsettling positions to occupy. Observatories continue to collect information. Models are adjusted, revised, tested again. Teams analyze the same data sets from different perspectives, searching not just for answers, but for consistency. Something stable, something that holds. But consistency is exactly what is missing. The anomaly does not behave the same way twice under identical expectations. It resists simplification. It does not collapse into a single explanation that can be shared, published, and accepted. And so, the response becomes silence. Not the absence of work, but the absence of conclusion. Because announcing uncertainty at this level carries weight. It challenges assumptions that extend far beyond a single phenomenon. It touches the reliability of models used across cosmology, physics, and our broader understanding of how the universe operates. So the language becomes cautious. Instead of saying something is wrong, it is described as inconclusive. Instead of calling it a failure, it is labeled an open question. Instead of admitting that the rules may not fully apply, it is framed as requiring further investigation. But behind that language, something else is growing. A recognition that this is not resolving. That no matter how much data is collected, the core issue remains untouched. The anomaly is still there, still behaving in ways that do not align with expectation. And that creates a different kind of tension. Not the tension of discovery, but the tension of limitation. Because science is built on the idea that, given enough time and enough observation, the universe will eventually reveal its patterns. That every mystery, no matter how complex, has an underlying structure waiting to be understood. But what happens when the structure does not reveal itself? When the more you observe, the less coherent it becomes. That is where silence turns into something else. Not ignorance, but the awareness that we may be approaching the edge of what our current understanding can reach. And beyond that edge, there is no clear path forward, only observation, and the growing realization that something is happening without explanation. It's getting worse. Up to this point, uncertainty could still be contained. A phenomenon without explanation is not unusual in science. It is uncomfortable, but manageable. It exists within the expectation that, eventually, patterns will stabilize, models will adapt, and clarity will emerge. But that expectation depends on one critical condition: that the phenomenon remains stable, and this one does not. Over time, the anomalies have not only persisted, they have intensified. What once appeared as subtle inconsistencies have become more pronounced, more frequent, and harder to dismiss. Signals that were slightly delayed now show greater divergence. Distortions that were barely measurable have grown into clear deviations. It is no longer something that requires careful analysis to detect. It is something that stands out, and more importantly, it is no longer confined. New regions are beginning to exhibit similar behavior. Areas of space previously considered stable are now showing early signs of the same irregularities. Not identical, but familiar. As if the pattern is extending itself, slowly, methodically, across distances that should isolate events from one another. This is where the tone shifts again. Because repetition suggests existence, but expansion suggests movement, and movement implies something active. The possibility that whatever is causing this is not fixed in place, not bound to a single location, but capable of influencing multiple regions over time changes the nature of the phenomenon entirely. It is no longer a question of where it is, but where it will appear next, and how far it can reach. At this stage, even without a clear explanation, one thing becomes difficult to ignore. The universe, which we have always understood as governed by consistent laws, is now showing signs of localized instability that does not remain localized. It spreads, not rapidly, not violently, but steadily enough to be noticed, and that introduces a new kind of uncertainty. Because if this progression continues, if the anomalies keep increasing in frequency and intensity, then what we are observing is not just a distant irregularity, it is a process, something unfolding. And like any process, it has a trajectory, a direction that we do not yet understand, but may not be able to stop. What this means for us. It is easy to believe that everything we have discussed so far is distant, far beyond our galaxy, far beyond any immediate consequence. A strange behavior unfolding in the deep universe, disconnected from our lives, our planet, our fragile existence here. But that sense of distance is an illusion. Because we are not observers standing outside the universe, we are inside it. Every law that governs those distant regions is the same law that governs the light reaching your eyes right now. The same structure that shapes galaxies is the structure that holds atoms together, that defines time, that allows cause to follow effect. There is no boundary separating us from what is happening out there, only scale. And if that scale begins to shift, even slightly, even in ways we cannot yet measure locally, the implications become impossible to ignore. Because what we are witnessing is not just a phenomenon in space, it is a behavior of reality itself. If the consistency of physical laws can vary across regions, if the framework we depend on is not as uniform as we believed, then stability is no longer guaranteed in the way we assumed. Not today, not tomorrow, but in principle. And that changes the conversation entirely. Because for the first time, the question is not only about understanding what is happening, it is about understanding whether what we consider constant will always remain constant. The idea that the universe is predictable has been the foundation of every technological advancement, every scientific model, every assumption about the future. It is what allows us to navigate, to calculate, to trust that cause and effect will remain linked. But if there are regions where that predictability weakens, then the universe is not a perfectly stable system. It is a dynamic one, and dynamic systems can evolve. The unsettling part is not that change exists. It is that we do not know the limits of that change. Right now, everything we observe suggests that these anomalies are distant, that they are contained within regions far removed from us. But distance, in a universe that expands, shifts, and evolves, is not a permanent barrier. It is a temporary condition. And that introduces a thought that is difficult to ignore. Not that this will reach us, but that we cannot say with certainty that it never could. The real question is not what, but why. At the beginning, the question seemed simple. What is causing this? It is the natural response to anything unknown. Identify the source, isolate the mechanism, build a model that restores order. That is how we have always approached the universe, and for a long time, it worked. But now that question feels insufficient, because every attempt to answer what leads somewhere incomplete. Each explanation accounts for a piece, but never the whole. The anomaly remains intact, untouched by the frameworks designed to contain it. And when the question of what fails to produce clarity, something else begins to emerge. Why? Not in the sense of purpose or intention, but in the sense of condition. Why here? Why now? Why in this pattern? Why does it evolve instead of stabilizing? Why does it appear structured instead of random? Because if this were purely chaotic, purely accidental, it would not hold its form. It would not repeat. It would not grow in a way that suggests continuity. And yet, it does. That forces a deeper shift in perspective, from viewing the universe as a fixed system governed by universal laws to considering the possibility that those laws may operate differently depending on conditions we do not yet understand. That reality itself may not be uniform, but layered, contextual, dependent on factors that lie beyond our current ability to measure. In that sense, the anomaly is not breaking the universe. It may be revealing something about it, something that has always been there, embedded in its structure, hidden not because it was invisible, but because we lacked the conditions to see it. And now, for reasons we cannot yet explain, those conditions are changing. That is what makes this moment significant. Not the anomaly itself, but what it implies. Because if the universe can present behaviors that fall outside our established understanding, then our models are not complete. Our assumptions are not final. What we call reality is still, in some sense, unfinished in our comprehension. And that realization carries weight, because it means that discovery is no longer about adding detail to what we already know. It is about redefining the boundaries of what can be known at all. And we're only beginning to notice. At the start, this felt like an isolated irregularity, a distant inconsistency, a quiet deviation buried in data, far removed from anything familiar, easy to dismiss as a temporary problem waiting to be solved. But now, after everything we have seen, that interpretation no longer holds, because what we are witnessing is not just an anomaly. It is awareness, not of something new, but of something that may have always been present, just beyond the limits of our perception. The universe has not necessarily changed. What may be changing is our ability to detect what was previously invisible to us. And that distinction matters, because it suggests that this is not the beginning of the phenomenon. It is the beginning of our recognition of it. For decades, our instruments have been improving. Our observations have become more precise, more sensitive, more capable of capturing subtle details across vast distances. With each advancement, we see deeper, measure more accurately, and uncover patterns that were once indistinguishable from noise. And sometimes what emerges from that noise is not clarity, but something unexpected, something that does not resolve as our tools improve, but instead becomes more defined, more structured, more undeniable. That is exactly what is happening here. The anomaly is not fading with better data. It is becoming clearer. And that raises a question that lingers beyond everything else. How much of the universe have we misunderstood simply because we could not see it properly? If these inconsistencies were always present, hidden within the limitations of our measurements, then what we are experiencing now is not the discovery of something new. It is the uncovering of something fundamental. Something that challenges the idea that the universe is uniform, stable, and fully governed by a single, consistent set of rules. Because if that assumption no longer holds perfectly, then everything built upon it must be reconsidered. Not discarded, but expanded. And expansion in this context is not comfortable. It forces us to confront the possibility that the universe is more complex than our current models allow. That there are layers of behavior, conditions of reality, that exist beyond what we have been able to observe until now. And if that is true, then what we are seeing is not the edge of the unknown. It is the edge of our awareness, a boundary that is slowly moving outward, revealing not just new information, but new questions. Questions that do not have immediate answers and may not have simple ones at all. Because the deeper we look, the more it becomes clear. This is not resolving. It is unfolding, and we are only at the beginning of noticing it. Closing loop. There is a region in deep space where reality does not behave the way it should. At the beginning, that idea felt distant, abstract, something confined to data, to instruments, to scientists observing from far away. But now, after everything we have uncovered, it no longer feels isolated. It feels connected. Because what started as a small inconsistency has revealed something far more profound. Not just a flaw in measurement, not just an unexplained phenomenon, but a shift in how we must think about the universe itself. We believed in uniformity, in a cosmos governed by stable, universal laws that apply equally everywhere, without exception. That belief allowed us to understand, to predict, to explore with confidence that reality would remain consistent as we pushed further into the unknown. But now, that confidence has been quietly challenged, not destroyed, just unsettled. Because if there are regions where those laws begin to drift, even slightly, even in ways we cannot fully explain, then the universe is not as fixed as we imagined. It is more dynamic, more complex, more layered than our current understanding can fully contain. And that changes the meaning of everything we have seen. The distortions in light are no longer just anomalies. The inconsistencies in time are no longer just errors waiting to be corrected. The patterns emerging across space are no longer coincidences. They are signals. Not signals in the traditional sense, not messages or transmissions, but indicators that something deeper is at work, something that does not fit within the boundaries we have defined. And perhaps never did. Because the most unsettling possibility is not that the universe is breaking. It is that it was never as stable as we believed. That what we call reality is not a single, unchanging framework, but a system capable of variation, of conditions, of behaviors that only reveal themselves under certain circumstances. And now, for the first time, we are beginning to see those circumstances. The anomaly that should not exist is still there, still expanding, still resisting explanation. But the question has changed. It is no longer just about what is happening in that distant region of space. It is about what that region is telling us about everything else, about the universe, about its limits, and about how much of it we truly understand. Because if something this fundamental can remain hidden until now, then one truth becomes impossible to ignore. We are not just exploring the universe, we are still learning how to see it, and we may have only just begun.